Imagine typing a single question into AI and instantly triggering a global chain of events. Every keystroke sets trillions of calculations in motion inside massive data centers. What looks simple on your screen unleashes extreme energy, heat, and yes, water consumption on an unprecedented scale. Are you ready to discover how your curiosity touches the planet's water? Your prompt travels at near light speed through fiber optic networks, reaching data centers across the globe. Each byte lights up rows of high-powered servers, blinking and humming with digital life. But here's the twist. These servers don't just consume electricity, they produce immense heat, forcing water-intensive cooling systems into action. And the scale will surprise you. Step inside a modern data center where towers of GPUs calculate endlessly. As computations spike, temperature rises and cooling systems roar to life. Pipes pump thousands of liters of water, some evaporating instantly. One small AI request, one video frame, and the invisible water footprint begins to grow. Can you imagine the hidden cost of your daily AI interactions? It's not just the servers. AI's electricity comes from power plants, many relying on water for turbines and cooling. This means your simple question triggers indirect water usage hundreds of miles away. From rivers to reservoirs, water flows quietly but massively, sustaining the digital magic you see. How did we reach a point where curiosity equals global water demand? Not all AI workloads are equal. Training massive models consumes far more water than answering a single query. Think of a marathon versus a walk. GPUs work non-stop, heat builds exponentially, and cooling towers run at full blast. The contrast is staggering, yet most users never notice. Could your next AI experiment have a hidden environmental ripple? Location matters more than you might think. Data centers in arid deserts burn through water faster than those in cooler regions. Heat, humidity, and evaporation rates dictate cooling intensity. Even the same AI prompt triggers drastically different water consumption depending on geography. This hidden variable explains why some regions feel the strain more than others. Modern data centers fight back with innovation. Closed-loop cooling, hybrid air-water systems, and recycled water dramatically cut consumption. Smart AI sensors adjust flows dynamically. Yet, despite these advances, every AI interaction still leaves a footprint. Are we ready to balance innovation with sustainability, or will curiosity continue to drain our planet's resources? Let's follow the water from the cooling towers back to its source. Rivers, reservoirs, and municipal systems feed data centers non-stop. Each AI prompt silently draws liters of water, often invisible to the naked eye. Your screen's magic relies on real-world resources. How much water does curiosity really cost? The answer might surprise you. Ever wondered why some data centers look like mini industrial cities? Towering cooling structures, endless pipes, and vast water tanks all work together to tame heat. Every server calculation has a ripple, demanding both electricity and water. This hidden choreography of technology and nature is rarely seen, but its impact is enormous. Heavy AI training is a different beast. Unlike simple queries, training massive models can consume millions of liters of water over weeks. Cooling towers run non-stop, heat exchangers sweat under pressure, and even recycled water barely keeps up. The next time you hear AI model training, imagine the invisible waterfall keeping it alive. Power plants amplify the story. Thermal plants, coal, nuclear, and natural gas facilities rely on water to generate electricity. Your AI video triggers indirect water use far from the data center. Rivers and reservoirs sustain turbines and condensers, connecting digital creativity to global ecosystems. One prompt equals far more than it seems. Geography plays a silent role in water demand. Desert data centers evaporate water faster. Tropical regions contend with humidity. Even two identical AI workloads can have drastically different environmental costs depending on location. Understanding this hidden variable is essential if we hope to measure AI's true footprint. The good news, innovation is reshaping the landscape. Closed-loop cooling, smart sensors, and hybrid systems cut water use dramatically. Futuristic campuses use air cooling or recycled fluids to reduce evaporation. Yet, despite technology, each AI interaction leaves a trace. How do we reconcile efficiency with endless curiosity? Now imagine the cumulative effect. Millions of users worldwide sending prompts every second. Data centers hum, cooling towers steam, reservoirs fluctuate. AI's water footprint grows quietly but relentlessly. This is the invisible story behind every video, every chatbot, every digital image, hidden yet crucial. Are we ready to face the reality? Even small daily AI tasks add up. A single chatbot response, image render, or video frame may seem trivial, yet multiplied by millions of users, the water footprint becomes staggering. Every interaction, every scroll, contributes quietly to global water consumption. Can we truly visualize the scale behind the digital world we take for granted? Thermal imagery of server halls reveals hidden heat. Blue turns to orange, orange to red, an invisible warning of energy and water intensity. This visual story helps viewers connect digital actions to physical consequences. The servers may hum silently, but their thirst for water is real. Will users rethink their AI habits? Training AI models is like running a massive industrial engine 24/7. Cooling towers roar, pumps circulate thousands of liters, and even recycled water struggles to keep pace. It's a silent, invisible industrial process happening to power the digital magic we see online. Are we aware of the environmental price of innovation? Indirect water consumption often surprises people. Power plants supplying electricity rely heavily on water. AI prompts indirectly drive water through turbines, condensers, and reservoirs far from the data center. Each query triggers a global ripple effect. How does this invisible chain impact our planet's fragile ecosystems? Location intensifies the challenge. Data centers in hot, dry climates use far more water than those in cooler, humid regions. Heat, evaporation rates, and ambient conditions dictate water intensity. This hidden environmental factor makes some AI operations far costlier in water than others. Can we design smarter AI infrastructure to mitigate this? Innovation is bridging the gap between curiosity and sustainability. Air cooling, hybrid systems, and closed-loop water circuits dramatically reduce consumption. Smart sensors modulate flows dynamically, and futuristic campuses prioritize efficiency. Yet even the most advanced systems cannot eliminate the footprint completely. How far can technology go? Now, picture millions of AI users worldwide sending requests every second. Servers hum, pipelines flow, cooling towers steam, reservoirs fluctuate. Invisible yet enormous, the water footprint of digital activity grows steadily. Understanding this connection is critical to responsible AI use. Are we ready to face the hidden cost of our digital curiosity? Every AI interaction leaves a trace in water systems. While the digital world feels intangible, behind every request lies a network of servers, pumps, and cooling towers consuming liters of water. This hidden ecosystem sustains AI magic. Can viewers reconcile the invisible water cost with the convenience of instant answers? Cooling towers release subtle streams of steam, a visual indicator of water loss. The evaporation is silent but significant, and each AI calculation contributes. Documenting these invisible flows connects digital activity to environmental impact. How often do users pause to consider the resource behind the screen? Power plants amplify water usage further. AI demands electricity, electricity demands water. Rivers feed turbines, condensers, and cooling systems far from the data center. Every pixel, every frame, triggers a chain reaction. The scale of indirect water use is astonishing. Will audiences grasp the full magnitude? Heavy AI training workloads are water-intensive by design. Weeks of calculations heat servers non-stop, forcing maximum cooling. Evaporation rises, pumps work tirelessly, and recycled water struggles to keep pace. One project, one model, and the hidden water footprint becomes massive. Can we visualize this unseen industrial process? Geography determines intensity. Hot, arid climates accelerate evaporation. Humid, cooler regions mitigate it. The same AI operation consumes drastically different volumes of water depending on location. Understanding this hidden environmental variable is key for sustainability planning. Are we designing AI with these factors in mind? Innovation reduces impact without sacrificing performance. Hybrid cooling, recycled water, and advanced sensors optimize flows dynamically. Futuristic air-cooled campuses demonstrate potential, yet no system is perfect. Each AI interaction still leaves a footprint. How can humanity balance curiosity, technology, and conservation? Global scale magnifies small actions. Millions of daily AI requests combine to create a significant water footprint. Reservoirs fluctuate, pipelines work continuously, and cooling towers steam silently. The digital revolution is powered by hidden resources. Are we ready to rethink our relationship with AI and the environment? Even casual AI tasks contribute. Every chatbot message, image render, or video frame silently triggers water use in data centers and power plants. Individually small, collectively enormous. The next time you click Generate, remember the hidden resources behind the screen. Could one prompt really ripple across the planet's water systems? Thermal overlays and server halls reveal heat patterns invisible to the naked eye. Red-hot GPUs, orange-hued racks, each indicates energy and water intensity. These unseen forces remind us that AI's magic is grounded in physical systems. Are we aware of the cost behind every calculation? AI training is industrial by nature. Continuous calculations generate intense heat, prompting non-stop cooling. Water flows, evaporates, and recycles in an intricate dance. Millions of liters support models unseen. The environmental price of digital innovation remains hidden from most users. Can we visualize this process clearly enough to care? Indirect water usage is surprising. Electricity generation for AI relies heavily on water. Power plants, turbines, and condensers far from data centers work silently, fulfilling the energy needs of digital processes. One AI prompt triggers a hidden network of global water consumption. Are users ready to face this reality? Climate and geography intensify water use. Desert data centers lose water rapidly to evaporation. Cooler, humid regions consume less. Identical workloads can have dramatically different impacts. Recognizing these hidden variables is crucial to building sustainable AI infrastructure. Can we adapt before resources strain? Technological innovation offers hope. Closed-loop cooling, smart sensors, and hybrid air-water systems dramatically reduce water consumption. Even futuristic AI campuses demonstrate measurable savings. Yet, no system is perfect. Every AI interaction leaves a footprint. How far can efficiency go without compromising AI capabilities? So, the cumulative effect is staggering. Millions of users, billions of requests, continuous server operation. Cooling towers steam, reservoirs fluctuate, pipelines flow. The invisible water footprint of digital activity expands quietly but relentlessly. Understanding this connection is key to responsible AI use. Are we ready to change our digital habits? Even advanced users rarely consider water behind digital convenience. Each AI interaction silently engages servers, cooling systems, and global power infrastructure. Invisible flows of water support visible outputs, images, videos, text. Could raising awareness about this hidden footprint change how we use AI daily? Visualizing AI's water footprint makes it tangible. Thermal overlays, flowing pipelines, and steaming towers illustrate the hidden ecosystem. One prompt may seem small, but multiplied across millions of users, the environmental impact is massive. Can our collective curiosity coexist with sustainability? Futuristic solutions promise balance. Hybrid cooling, recycled water, air-based systems, and smart AI sensors optimize resource use. But innovation alone cannot eliminate water use entirely. Each interaction leaves a trace, reminding us that digital progress carries responsibility. Are we ready to act responsibly? Global AI adoption magnifies small choices. Each user's click triggers water use far from view. Rivers, reservoirs, and power plant systems operate in the background. Invisible yet impactful, the cumulative effect demands awareness. How can we design AI experiences that respect the planet's resources? From one simple prompt to a worldwide water network, the story of AI is a tale of hidden resources. Every question, video, or image leaves a footprint. Awareness is the first step. Sustainability is the next. The next time curiosity strikes, remember, digital magic is powered by real water. Are you ready to make mindful AI choices?
For cooling.